Hello friends, welcome to the channel Chemoland.
Today we will learn what is a nucleophile and what is a electrophile.
Nucleophiles and electrophiles. What does this mean for nucleophiles and electrophiles? Well, in general, filled orbitals tend to be low in energy. That is after all why they are filled. Conversely, empty orbitals tend to be high in energy. So the best interaction, the one that gains the new molecule the most energy, is likely to be between the highest in energy of all the filled orbitals. And orbital we can term the highest orbital molecular orbital, or HOMO for short. And the lowest in energy of all the unfilled orbitals, the lowest unoccupied molecular orbital, or LUMO for short. This diagram may help you to clarify this idea. It's a repeat of the best interaction above, but with other orbitals sketched in. This is the definition of electrophiles, from where we can deduct an electrophile. Electrophiles are neutral or positively species with an empty orbital, such as the empty p orbital in boron, or a low energy antibonding orbital that can easily accept an electrons. So empty orbitals and a low energy antibonding. So we can easily treat as this definition whole in a LUMO. This LUMO. Let's see the examples. Like in AlCl3, where this is an empty orbital which can take the electrons from the HOMO of nucleophiles, and this is a LUMO, a vacant p orbital. Another example is the VF3. This is a vacant p orbital which can take the electron from the HOMO of nucleophiles. So a HOMO can give its electron to this LUMO of VF3, this HOMO of a nucleophiles. This is a nucleophiles HOMO which donates its electron to the vacant p orbital, which is known as LUMO of BF3 molecule. Let's see more examples. Electrophiles accept electron into empty low energy orbitals represented by one of the following. So let's write down the examples first. Carbonyl group compound and HCl. So this a positive charge representing an empty orbital. This is a positive charge representing an empty orbital. You can write these words: a positive charge representing an empty orbital. This a neutral molecule with an empty p orbital. A neutral molecule with an empty p orbital. A double bond to an electronegative element. A double bond to an electronegative element. A single bond to an electronegative element. A single bond to an electronegative element. You can represent this as like HCl. LUMO, here LUMO is the sigma star orbital. Here LUMO is the sigma star orbital. Let's see an example. Sodium borohydride will react with a carbonyl compound, so by transferring a hydride transfer, this. So here this is a electrophile file, and this plays the role of an nucleophile. Okay, there are more examples of electrophiles, like a benzyl compound. This is the LUMO. The definition of a nucleophile, that nucleophiles are either negatively charged or neutral species with a pair of electrons in a high energy orbital, which I have already told you that nothing but HOMO. The most common type of nucleophile has a non-bonding lone pair of electrons. What? Non-bonding lone pair of electrons. So this is the definitions. Nucleophiles are either negatively charged or neutral species with a pair of electrons in a high energy orbital, which is HOMO. The most common type of nucleophile has a non-bonding lone pair of electrons. What? Non-bonding lone pair of electron. So there are different types of nucleophiles. So let's see the examples, or you have to know that how to identify the nucleophiles. There are different types of nucleophiles, like nucleophiles with a lone pair. So the nucleophiles with the lone pair. Examples, what are the examples? Like ammonia, NH3. This is the lone pair, okay? And NR3, trimethylamine or trialkylamine, whatever. And our water, H2O. This is the lone pair of oxygens. So this is the lone pair. Nucleophiles with a lone pair. So let's see. Like we know that ammonia is sp3 hybridized. So this is the hydrogen, and this is the lone pair. So this will take part in the reaction as a electrophile, no, as a nucleophile, sorry, as a nucleophile. And it is a HOMO, HOMO, highest occupied molecular orbital. There are more examples, like nucleophiles with negative charge. Okay, what are the examples? Hydroxide ion, bromide ion, and cyanide ion. And this is the important, one of a important nucleophile, this cyanide. The most important carbon nucleophile with a lone pair of electrons is a cyanide ion. What? The most important carbon nucleophile with a lone pair. Let it draw it, okay? How is it looks? This is a C double bond N, and nitrogens have a lone pair, okay? Carbon has a lone pair, and this is the negative charge, okay? This is a negative. This is our carbon nucleophile. There are more examples, like a nucleophile with a C double bond C, okay, double bond, okay. These are the topics, so I underline it, okay. What I have told, that C double bond C. What are the example? Let's see this. See. Ethene. Let's ethylene. Okay. This is what? A sigma bond and a pi bond. This is a electron cloud. What? This is a electron cloud. This you can set this the electron cloud, this. So we can write HOMO as a bonding pi orbital, okay. Especially the cis double bond C, since they are higher in energy, or as HOMO. However, that molecules with pi bonds can also be electrophiles, particularly when the pi bonds involves as a electronegative atom, whatever. So this is our nucleophile. Now next examples, let's see. Nucleophiles with a sigma bond. What? This is a sigma bond between electropositive atoms. This is another name you can take as organometallic reagents, okay. So nucleophiles with a sigma bond between electropositive atoms. What are the examples? Like this boron hydride, this, and here is a negative, okay. This you can take it this, and also write HOMO BH sigma orbital. So it acts as a nucleophile. More example, let's take lithium. What? This is a lithium. You all know that the electronegativity of carbon is greater than lithium. So this, okay. So this bond attacks towards the electrophile, okay. Now we will classify the nucleophiles. So you can write down as a topic classification of nucleophiles. Number 1, negative charge species. Negative charge species. What are the examples? Easy. You can easily identify now that SH minus, SR minus, Cl minus, bromide, iodide, etc. Okay. In number 2, I have this said that organometallics, so you can name it organometallic reagent, which all basically acts as a nucleophile. So R minus MgX, this you know Grignard reagent, R minus lithium, R2 minus Cu copper lithium, R2 minus cadmium, R2 minus zinc, and etc. Now at number 3, lone pair containing species. Sorry students, my handwriting is quite bad, so you can take a screenshot and write clearly that H2O, basically water, and alcohol, here is a lone pair, ammonia, lone pair on nitrogens, iodine sulfide, and also pyridine. Okay, these are the lone pairs. And also you can another participate it, that pi bonded nucleophiles. So what are these? Like alkene, alkynes, okay. Benzene also reacts as a nucleophile, benzene, or this, okay, etc. So this is the concept of nucleophile. Write down all the examples of nucleophiles and also the definition of nucleophile. It's important that non-bonding lone pair and the HOMO, okay, these two concepts are more important for the definition of nucleophiles. This is the basic definition of nucleophiles and best ever. Thank you.
Hello friends, welcome to the channel ChemoLab.